Now available from National Geographic Home Video.
There is a place where dinosaurs once ruled, until the winds blew across the desert and the dinosaurs were no more. But they left their secrets buried in the sand.
That's really a great fossil find because it's one of the rare instances where we can capture a little bit of behavior that's 80 million years old.
Take a new look at one of history's oldest mysteries when National Geographic Television takes you to the heart of the Gobi with the Dinosaur Hunters.
Natural disasters, they can strike without warning. Savage reminders of our fragile existence. Shattered lives, ravaged property. If you make it through alive, you hope you'll never again face nature's fury. Earthquakes and floods, tornadoes and hurricanes. These catastrophes shake our very foundations. Sometimes they happen in the blink of an eye. Sometimes they're slow, relentless death. National Geographic takes you to Bangladesh, Mexico City, the American Midwest. All over the world, nature's unleashed power kills thousands of people and leaves thousands more to pick up the pieces in despair. Will fighting these natural-born killers always be a losing battle, or can we learn to survive nature's fury?
And now, our feature presentation.
When he first came to the high desert, Gene Shoemaker wondered if he was too late. Was the West all explored? The battles fought? Mysteries solved? But geologists are taught that truth lies in the rocks and dirt underfoot. Step by step, he pressed the earth for its secrets. What Gene Shoemaker found has made the ground itself less firm. Planet Earth not nearly as safe as we always assumed.
It's like being in a hail of bullets going by all the time. They are bullets. They're bullets out there in space. These things have hit the Earth in the past. They will hit the Earth in the future. It will produce a catastrophe that exceeds all other known natural disasters by a large measure.
Before Gene Shoemaker, few people gave it much thought. One of the most powerful forces in the making of our planet, and perhaps the deadliest hazard we face. This is the story of impact. March 23rd, 1993. Great telescopes around the world aimed their sights deep into the night. They were peering far into space, searching for traces of the Big Bang at the outermost reaches of the universe. But at one tiny telescope on a lonesome peak in California, three old friends were rummaging in a part of space much closer to home.
5, 4, 3, 2, 1. I'm on.
Gene Shoemaker, geologist, was looking for rocks, not on the ground, but in the sky. That night, he and his team found something astounding, a portent of another kind of Big Bang. Comet Shoemaker-Levy 9 first appeared as a faint smudge in space. It grew into a blazing streak of light. By the time it smashed into Jupiter, every major telescope in the world was watching. The impact unleashed fiery plumes large enough to incinerate the Earth, and it raised a terrifying question. Could it happen here? And what if it did?
When we get to something in the ballpark of a mile in diameter hitting the Earth, it'll produce a catastrophe that exceeds all other known natural disasters by a large measure. In fact, the energy delivered would be like taking all of the world's nuclear weapons, putting them all in one pile and setting them all off at once. Actually, it'd be a little bit more energy than that.
Once scientists had said it could never happen. Now many were shocked. Some talked about the end of the world.
If something sneaks up on us, then there's very little we can do. In fact, today, the most likely situation is zero warning. The next impact of a mile-sized object will probably happen without any prior discovery of it at all. The first thing you will know is when you feel the ground shake and see the plume of fire coming up over the horizon.
He'd been taught cosmic collisions are inconceivable. But Gene Shoemaker likes to make up his mind for himself.
It was a path that I personally traveled in small steps. I had to teach myself that, in fact, if one really pursues the observations, the world is telling us that big things do fall out of the sky.
What the world told Gene, it said most eloquently at Meteor Crater. The gaping hole in the Arizona desert, nearly a mile wide, spoke of sudden disaster, catastrophe falling from the sky with deadly impact. There were similar craters in other places, but most geologists said they were the remnants of ancient volcanoes, formed over eons of time by constant predictable forces. Nothing this big happened quickly or suddenly. Fiery rocks falling from the sky have long been believed to predict disaster, not cause it. Meteorites have been feared as omens and cherished as relics around the world. For thousands of years, they were our only way of touching the sky, mysterious messengers from space. The intrigue they held for ancient oracles still captivates modern scientists. It was inside a meteorite, a Martian rock that landed in Antarctica, that researchers discovered the most compelling intimation ever of life beyond the Earth. Meteorites are chunks broken off larger celestial bodies. When they crash through Earth's atmosphere, most lose speed and power, so even big ones measuring up to 10 feet across usually don't cause damage on a large scale. Still, if you or your house happen to stand in the path of a stone from space, repairs will be necessary. Tons of meteorites rain on the Earth every day, most smaller than a pea, but that's enough to light up the night. This fireball was seen by thousands of people along the eastern seaboard in 1992. Many were attending high school football games, and some had brought their video cameras. A piece of the meteorite touched down in Peekskill, New York, and cratered Michelle Knapp's 1980 Chevy Malibu.
I was sitting in my house watching TV, and next thing you know, I heard this loud noise. It sounded like a car accident.
It was a chunk of stone speckled with iron, about the size of a football.
They told me the rock was estimated at 4 billion years old, which is about as old as the Earth itself. And that's exciting.
The Peekskill meteorite did make the local news, but like most meteorites, its impact was minimal. In 1972, a rock the size of a bus blazed so brightly it was seen in daylight and was filmed by a tourist near the Grand Tetons. There was no impact, confirming what most scientists thought, that Earth's atmosphere would incinerate even giant boulders or break them into relatively harmless pieces. What was it then that violently shook the Earth on June 30th, 1908? A blinding fireball exploded over a remote part of Siberia. As far away as England, an eerie glow lit up the sky. 2 decades passed before scientists could mount an expedition to find the site where the blast occurred. It was an arduous trip to an uncertain destination, but the scientists knew they had arrived when they saw the staggering devastation on the banks of the Tunguska River. Over hundreds of square miles, the forest lay flattened in vast concentric circles. The scientists suspected the destruction had been caused by a huge meteorite, an asteroid. They set out to unearth it. Long months spent draining the swamps and digging into the wasted land yielded nothing. For years to come, Tunguska would remain one of the great mysteries of the Earth. At about the same time, on the other side of the globe, a similar mystery haunted this giant bowl in the Arizona desert. In the early 1900s, Daniel Beringer, a mining engineer, found little chunks of meteorite around the crater. He drilled the crater floor in search of an asteroid, but came up empty-handed and deeply disappointed. Geologists weren't surprised, but years later, a young Gene Shoemaker was intrigued. What had happened here? It did seem like a giant wound in the earth. It appeared as though the ground had been dealt a devastating blow. Massive beds of rock that once lay flat were broken and thrust violently into the air. The rim was strewn with giant limestone boulders that could only have come from deep beneath the surface, flying hundreds of feet in the air. But like all geologists, Gene had been taught that even the most dramatic landscapes took shape at a creeping pace. Meteor crater could not in fact be a meteor crater.
People say, yes, meteorites fall out of the sky. We accept that. A chunk that big, I accept that that falls out of the sky. But it was an intellectual leap to go from a fist-sized stone to a mountain and have a mountain come down out of the sky. As an undergraduate student, I didn't learn anything about impact. It wasn't part of geology at that time. Geologists are kind of folk that like to say, I'd like to see what the process is. I'd like to see it happen. Then I believe that it's happened in the past.
Gene Shoemaker was one geologist who saw something happen that would lead him to question the fundamental principles of his profession. He was in his 20s when he took on a job at the top-secret Nevada test site. Here he witnessed a new mechanism by which craters could be made.
It all takes place in utter silence until finally the shock wave. Bam! And then it's followed with roiling thunder. It's throbbing, and you can feel the sound in your whole body. And that's a very dramatic thing to watch, too.
Never before had so much energy been harnessed or released. Could nature do the same? This crater had not taken shape over thousands of years. It was created in an instant, and it reminded Gene of another place he'd seen.
It was the largest crater at the time formed by a shallow underground explosion. And so I could go directly from this to Mother Nature's crater. My hunch was that I would go have a look at Meteor Crater and see what the structure was, because it had never been thoroughly mapped and described. And so I didn't know what the structure was until I went. But having mapped this first, I went to Meteor Crater, and voila! I was astounded that all of the parts of the crater that I could see in the little nuclear crater were reproduced here on a giant scale, including right down to the pieces of melted material.
Around the crater, Gene found tiny beads of glass, rock that had been melted and sprayed out. He'd seen these too in Nevada. Some rocks would reveal a newly discovered mineral, kozite, an intensely squeezed form of quartz that no volcano is powerful enough to produce. In this microscopic sample was encoded a story of violent devastation wrought by a 100-foot asteroid hurtling so fast the atmosphere could not slow it down. Gene Shoemaker had found the fingerprint of impact. It was the first conclusive proof of an impact crater on Earth. An affront to centuries of scientific conviction, and a challenge even to the professor's devoted students. Dr. Susan Kiefer once studied with Gene in graduate school.
One day, Gene said, "I'm going to show you what an impact is." So he grabbed a fairly large rifle, and we...
This is my favorite rifle.
I don't want to see this rifle again after what happened that day.
You recognize this suit?
And then Gene told me to shoot the rock, which I did.
What happened is it just kicked.
The rifle came back and hit me in the nose and broke my glasses. And he looked at me and said, "Haven't you ever fired a gun before?" And I said, "No."
It's all right.
Here's Annie Oakley with her nemesis. The ideas that Gene was proposing not only made individual people uncomfortable, but at a gut level, whole schools of academic thinking. That was the battle that had to be fought against. And he, I feel, really did that almost single-handedly.
That's a nice looking crater.
Sue's lesson was simple but revolutionary. A relatively small object traveling at great speed will blast a huge hole upon impact and at the same time almost completely disintegrate. The mysteries of Tunguska and Meteor Crater were solved.
It came from over there, from that direction. We look up in the sky, and we see a brilliant fireball that's being made by the asteroid, or meteorite as it's coming in, and it gets brighter and brighter and brighter.
Gene's explanation of meteor crater was controversial, but the reason he studied craters in the first place seemed downright crazy. When he was 20 years old, more than a decade before the space program, Gene had a hunch America would soon go to the moon.
And why would you go to the moon? To study the moon. And who do you send to study the moon? You send a geologist, right? I was going to do whatever I could do to stand at the head of the line when the time came to be the geologist chosen to go to the moon. Can you imagine any greater adventure? I couldn't. I thought, well, I better learn something about craters.
Oh, Gene, that's great.
Oh, look at that. I'm ready.
Gene dared confide his dream only to one person.
This was 1951. When we first met, I just thought she was the neatest gal I had ever met. That's it.
His wife, Carolyn, would become his lifelong accomplice in dreaming and scheming.
What attracted me to you?
What's that?
I think it's your enthusiasm about things. Gets this big smile, and you know he's just full of joy and enthusiasm for what he's talking about. Gene has a way of getting what he wants.
We choose to go to the moon. We choose to go to the moon.
In the early 60s, it seemed Gene might actually get what he wanted most.
We choose to go to the moon in this decade and do the other things, not because they are easy.
America was going to the moon, and he was already an expert on craters. There were many thousands of them on the near side of the moon alone. Gene believed they could yield tremendous knowledge about the role of impact in shaping not only the moon, but the Earth as well.
The moon is this slate that nobody's been erasing. The record that we're seeing of bombardment, all of those craters that we see on the moon, are a record of the flux, of the hail of bullets coming by that's hitting both the Earth and the moon. If we want to see what a very fresh, big impact crater looks like when it's first formed, we look at the moon. That guy up there.
The people who ran the space program didn't look at the moon that way. They were pitted in a furious race. What mattered to them was getting there, not what could be learned once we arrived.
There's no question that NASA managers, NASA engineers, and indeed the astronauts themselves were not particularly interested in doing science in space. That was not their mission. They had signed up to beat the Russians to the moon. And the farthest thing from anybody's mind was actually doing some science and collecting some samples. But nevertheless, even though he was considered probably a weirdo by some in the engineering community, Gene did not give up in trying to push this idea that doing geology on the moon was important.
But geology on the moon was a hard sell. Few scientists thought Gene was right about the effect of impact on the Earth, much less the moon. Many believed lunar craters, too, were old volcanoes. Before Gene got to ride a rocket, he took a fateful trip in a more modest vehicle. The Shoemakers were on vacation in southern Germany. Gene was eager to come here to visit the Reese Basin, a 15-mile wide depression that was universally believed to be an ancient volcano. Gene and Carolyn went strolling through the medieval town of Nördlingen in the heart of the crater. And there Gene came upon the largest geologic sample he'd ever found. St. George's Church, 500 years old, was built of local stone.
Just looking at the rock made me stop and say, whoa, wait a minute, what's this? I think I know what this is because I've seen something like that before.
The walls were riddled with glass formed from shocked and melted rock. Gene didn't need a microscope to know they contained kozite.
He was thrilled beyond words, and I was for him.
Just to go along and just admire all of this evidence for impact and the formation of a giant crater, and here it is incorporated into the cathedral, and it was just a very strange and interesting feeling, and saying, ah, yes, you know, we know what this is now.
The Reese is nearly 20 times as big as Meteor Crater.
It was the first big impact crater on the Earth which we could prove was an impact crater. And that just changed the whole ball game.
This was impact on an entirely different scale, brought on by a mile-wide boulder that drastically changed the landscape 15 million years ago. Suddenly, giant circular scars of impact were recognized all over the globe. Some were 200 miles wide.
Now we really understood there were big craters made on the Earth, and of course that meant those big craters we saw on the Moon, which I was also pretty sure were of impact origin. Now we had a way of saying, yes, it's happened on the Earth, the proof is here, but they're also on the Moon.
Gene had finally earned the credibility to convince NASA and the United States Geological Survey to establish a program aimed at doing geology on the Moon. Gene was appointed to run it.
Dr. Shoemaker, as the man in charge of the astrogeology program, what are you telling the astronauts to look for when they start exploring the Moon?
Small features of the Moon that will be close by around the landing site. And of course, we also want them to bring back a large number of samples.
Gene brought the Apollo astronauts to his favorite hole in the ground to teach them geology.
This seemed to me like a natural place to train astronauts who were going to go to the Moon and look at craters. In fact, the best place in the world for it. You really get a feel of what a crater's like, and every one of them wanted to get on the Moon. So they wanted to have a good idea of what they were going to get into.
For added realism, Gene's team blasted a replica of a lunar crater field not far from his home. There he participated in the design and testing of many of the vehicles and tools used on the Moon. Gene's youthful dream was becoming a reality. His vindication as a scientist and his greatest adventure would soon be won.
Seconds and counting. Guidance internal. 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. Engines on. 5, 4, 3, 2. All engines running. Launch commit. Liftoff. We have liftoff 49 minutes past the hour. 17 Houston, you are go for orbit. Go for orbit.
No, I'm not going to make it to the Moon.
Just at the critical time when I could have been standing at the head of the line to go to the Moon,
my adrenal cortex, my adrenal glands, stopped functioning. And I knew that would just knock me out of the running, medically. When you had that idea in your head for 15 years, it doesn't go away right away.
Gene remained with the lunar program as one of its chief scientists. His dream of doing geology on the moon came true vicariously. His friend and protege, Dr. Jack Schmidt, flew aboard Apollo 17. As Gene watched, his theories about the effects of impact on the moon were confirmed live on TV.
Down to it and back up. These are big rocks, so they'll come out easy.
Every rock you looked at, you pick up a rock or look at a large boulder, and there's a little pit there that's caused by a micrometeor impact. It became clear that the dominant geological process on the moon was meteor and cometary impact.
If I go down there, that thing's about 15 feet deep.
I was immensely pleased and proud of Jack, but of course I was wistful too. I couldn't help feeling that there, but for that failed adrenal gland, go I.
We're getting in your bag here. Got it?
I used to have dreams that I got there, you know. I got to the moon. I was there doing geology. Even afterwards, you know, for a long time. I had to go do other things.
His feet would never leave the ground, but Gene was intent on making his own way into space. He'd found the scars of impacts that happened in the distant past. Now, he'd be one of the very first to find out if there were bullets out there that might strike the Earth in the future. It was an obscure, lonesome effort and involved frequent night-long drives to an observatory far from home. But in time, Gene found a new collaborator and companion for the road. A housewife who decided she too would become an astronomer. For Gene, it was a journey from deep disappointment to new dreams and adventures.
I had some real misgivings because I thought, this means that I'm going to go to Palomar and I'll have to stay awake all night long and observe, because I'd never stayed awake all night in my life. It was kind of a surprise to me to discover that I really loved the observing. I could, if I was very busy, stay awake all night.
In the early morning hours, the shoemakers would wend their way up Palomar Mountain, home to what was then the most powerful telescope in the world. The 200-inch Hale was the temple of deep space astronomy. It was called the Big Eye and was not designed for observing asteroids. In fact, before Gene came along, no one here or anywhere else had ever systematically searched for asteroids that could hit the Earth. Down the slope from the Big Eye was a tiny telescope that was virtually unused. The Little Eye was just what Gene needed.
This is kind of suited to our style and level of effort. We call it our mom and pop operation, and that's basically the way we've done it. Turned out to be a perfect instrument for our purposes.
Compared with the giant up the slope, the Little Eye did not look far, but it looked very wide. It was ideal for patrolling the inner solar system for stray bullets. Most astronomers saw the solar system as a harmonious arrangement of planets orbiting the sun. They paid little attention to the hundreds of thousands of asteroids, chunks of iron and rock left over from the formation of the major planets. Most of them orbit harmlessly between Mars and Jupiter, the asteroid belt. But if an asteroid veered out of its normal orbit, into one that cuts across the path of the Earth, it would be anything but harmless. Most scientists believe that asteroids almost never became Earth crossers. Were the Shoemakers searching for something that wasn't even there? The answer would not come easily. Asteroids look so small on film that Carolyn had to look for them with a microscope. Even then, they would be almost invisible amid the stars. But slowly they emerge from the dark, tiny dim blurs. Since they're so much closer to Earth than the stars, they seem to streak through the sky. In 1989, other astronomers captured the first ever close-up of an asteroid using a giant radar dish. This huge rock was more than a mile across. Later radar images showed even more ominous asteroids, mountains tumbling through space. Tutatis, a giant boulder doing 70,000 miles an hour, regularly cuts across the path of the Earth. 951 Gaspra, first of only 2 asteroids ever to be actually photographed, is as large as the island of Manhattan. (243 Ida is more than twice as large. Like Gaspra, it isn't an Earth crosser. But if it were, it could blast a hole as wide as the state of Texas. Gene didn't make it to the moon, but together with Carolyn, he's discovered scores of new celestial bodies. Between them, they found hundreds of asteroids and dozens of comets, and helped transform the map of the sky. The solar system would never again seem stable or predictable. The harmony of the planets turned into a threatening cacophony.
What we've been able to show using this good old telescope right here, and by concentrating on surveying a near region around the Earth, we've been able to show that the Earth revolves around the Sun in its own swarm of asteroids. These things will hit the Earth in the future. They have hit the Earth in the past. These are the Earth-crossing asteroids.
In the 1980s, new evidence emerged of the terrible threat impact poses to life on Earth. Deep beneath Mexico's Yucatan Peninsula is a 190-mile wide crater made by a 100 million megaton impact. It dates to the time 65 million years ago, when 2/3 of all living species, including the dinosaurs, disappeared from the face of the planet. On March 22, 1989, an asteroid came within 6 hours of striking the Earth, but was not detected until much later. Other asteroids have come even closer. One would have hit the Earth if it had come just 4 hours sooner.
I don't think that people took the notion of the hazard of impact seriously in the early days of our work here. First of all, it took a while for the news to get out.
The news that would change everything began to break on the night of March 23, 1993. The Shoemakers and their collaborator, David Levy, decided to take some pictures of the sky despite persistent clouds. This was not a good night for observing, much less for making historic discoveries.
5, 4, 3, 2, 1.
Open. I'm on.
Okay, you're on.
I could hardly see the star I was supposed to be following because Jupiter was so close that the glare of the big planet was swamping the eyepiece.
5,
Okay?
All right, and plus 3759.
Okay.
I started to examine the film, looking at all the things that I knew would be there, the ghost image of Jupiter and the spikes that we see on the films when we've got a very bright star or a bright planet. And then I started to go by something, and I thought, that's a galaxy? No, that's not a galaxy. And here was this most unusual looking object, and I thought, it looks like a comet.
It looked like a comet, all right, except it was a comet that was stretched out. Our films don't have enough resolution to really see what the details are, because we're covering a big area of the sky, and so the comet's actually quite tiny.
The team called their friend astronomer Jim Scotty, who was manning a more powerful telescope, and asked him to check their finding. He promised to call back as soon as his telescope could be repositioned.
Well, by now it's about 2 hours that has gone by. And then I decided the time had come. Jim had had enough time to take a look, and I called Jim Scotty, and he answered the phone in a voice that I had never heard before. And I said, Jim, are you okay? And he says, yes. David, the sound you heard is me trying to pick my jaw off the floor. And I said, do we have a comet? And he said, boy, do you have a comet. And he started describing what he saw, and I was repeating everything to the two of you. And every sentence, it had these 5 tails, at least 5 discrete nuclei, but he said, I think there's more. And meantime, that music, we had just had Beethoven's First Symphony that was playing in our room, just happened to be on. And the 4th movement started, and it starts with this very slow little introduction. As Jim said, boy, do you have a comet? Then the symphony went into its full motion. And then right at that point, Jim says, boy, do you have a comet?
The comet, essentially an asteroid with a long tail of dust and gas, had been torn into several pieces by Jupiter's gravity.
Of course, the big kicker, the big news that it was going to hit Jupiter, didn't arrive until about 6 weeks later.
Here is this man looking at a computer screen, and it's saying, your comet, with your name on it, is going to collide with Jupiter in 14 months. And Gene was sitting there, and he was looking at it, and he was shaking his head, and he said, I don't believe it. I'm going to see an impact in my lifetime. I just don't believe this.
Now the question is, what was going to happen? Were we going to have a big show, or was it going to be something that no one could see?
Even as Shoemaker Levy 9 approached Jupiter, some eminent scientists remained skeptical it would make much of an impact. Many astronomers believed the giant planet would swallow the comet into its vaporous depths. On July 16, 1994, when the comet's leading fragment was due to cross Jupiter's path, scientists and reporters gathered at the headquarters of the Hubble Space Telescope. Gene found an empty office to call for news from distant ground-based telescopes.
We have heard that there have been some observations from Spain.
Dan? Gene Shoemaker.
In which I want to hear that.
The question is, how soon will Brian be?
There would be no reliable data until the Hubble team downloaded the day's first images of Jupiter.
See if there's nothing in the sky.
And they did, in fact, detect the plume.
In the auditorium, Gene had little more information than the gathered reporters.
We should all take these reports very carefully and cautiously at this time. They need to be confirmed.
Yeah, that's it. That's it. Look at that.
The tiny spot on Jupiter was, in fact, a fiery plume about half the size of the Earth.
Thank you, Mr. Mayor.
I'd like to introduce Dr. Heidi Hamill.
We just downloaded the first 2 orbits, which I have a raw laser printer output. This is as raw as it gets. We can actually see the impact site itself. And I'll remind you, this is for A, the first one, not the brightest one. So we're going to have a really exciting week.
I think we're very, very privileged tonight to see an event that's not once in a lifetime, it's once in a millennium.
Gene's vindication was a long time coming. Now it arrived with a 1,000,000 megaton bang. Few scientists have seen their ideas demonstrated on this magnificent scale.
That was one great moment in our lives.
That it vindicated what Gene had been trying to tell everybody all these years. And that the SL9 impacts spelled it out in black and white. That, Gene, you got it right.
Over the next week, some 20 separate pieces of the comet rained spectacular devastation on Jupiter.
If anyone had any lingering doubts that collisions take place and that they can have frightening consequences, watching those events on Jupiter convinced us.
To actually finally see an impact on a planet was crossing a threshold. That event finally convinced most of my geological colleagues that yes, there really are large impacts, not just on Jupiter, but on the Earth as well.
Could you imagine what SL9 would have looked like in its 21 pieces if they had been near the Earth?
Had any one of the fragments of SL9 hit the Earth, one of the bigger fragments, we probably would have had a dark cloud covering the whole Earth in the time of an order of an hour and a half. And we saw that the clouds on Jupiter lasted for months as fairly dark clouds.
But what about even before the cloud? What about the rising temperatures with the infalling material?
What about before that? If people knew that a fragment was going to hit the Earth, I wonder about the mass hysteria that could have resulted. Where would you go? People would say, where can we hide? What can we do?
You would feel as though you were in an oven turned on to broil. An enormous hole has been gouged in the Earth, and then finally the sky will just turn black. Absolutely, completely black. Everywhere, all over the world.
Impacts today are a risk. They're a hazard. They're something we need to protect ourselves against. If we don't learn how to protect ourselves against impacts, then on the long term, we are likely to be wiped out by impacts. If it happened to the dinosaurs, it could happen to us.
In SL9's wake, scientists and weapons experts from Russia and the United States met at Lawrence Livermore National Laboratory.
Fires, you've got massive tidal waves. So we have
The topic was the end of the world.
multiple mechanisms to produce extinction. You're going to have everything burned down around you. You're going to
Asteroids big enough to kill a quarter of the world's human population collide with the Earth about twice in a million years. Smaller bodies capable of wiping out a major city could hit once every 2 to 3 centuries.
It's going to glow for about a half an hour and set everything on fire around you. Then it's going to be pitch black.
One thing that makes the comet and asteroid impact hazard so important relative to other hazards is that it is the one hazard that is capable of killing billions of people, of putting at risk our entire civilization. We could have any number of storms or earthquakes or volcanoes, and they can do terrible damage locally, but they do not put the entire planet at risk the way an impact does.
Incredibly, impact is the one great natural disaster which we may be able to prevent. Many of those gathered at Lawrence Livermore were veterans of the Cold War and already knew something about confronting assault from the sky.
Two-dimensional simulations, obviously, of course, carry kinetic energies characteristically about 100 times their mass in chemical high explosive.
You have a rocket going after it. In this case, a nuclear explosion. You blow off some material, you get a reaction in its perpendicular direction, which here I've shown as being perpendicular to the closing velocity.
If an approaching asteroid or comet is detected in the near future, the scenario might involve the most powerful long-range rocket in the world, the Russian Energia. Tipped with an accurate American warhead, the rocket would be detonated off the surface of the asteroid, nudging it out of its Earth-approaching orbit. But before you launch a missile, you need to know where to aim. Only a fraction of large Earth-crossing asteroids have been located. This may prove to be the greatest oversight in human history.
I tell you but I can tell you nothing about the 90% that we have not yet discovered. So, yes, we understand the general nature of the risk, but we have not yet taken any real concrete efforts to protect ourselves or even to look and see if there's anything headed our way.
More telescopes have joined the search. Even the U.S. Air Force has contributed technology and expertise. Big science has taken up the hunt for asteroids. Still, the most experienced team in the business is leading the charge from a tiny new telescope in their backyard.
Both Carolyn and I, we're eyeball scientists.
We like to look at the sky.
It's kind of an old-fashioned brand of science, eyeball science, eyeball observations. But there's still a window there for the eyeball scientist who's got the right idea to go and make wonderful discoveries.
Gene and Carolyn Shoemaker should know. It's the story of their lives. Now they await with all of us the next messenger from the stars. The question is not if, but when.
We hope you have enjoyed this presentation from the National Geographic Video Library.